Welcome back to Cloud Computing. Today we are starting a new chapter, Chapter 4, which is all about fundamentals of cloud system. Up until now, we have been looking at the bigger picture, what cloud is, its history, and why organizations use it. Now we are going to zoom in and study its actual structure. Who plays what role, what boundaries exist, what makes the cloud different from traditional IT, and how different models of cloud delivery and deployment work. By the end of this chapter, you will have a clear framework for understanding how cloud is organized. And starting with chapter 4. This chapter primarily covers five major areas. First, we will look at the roles. Roles is the different positions people and organizations take when they interact with the cloud resources. Then we move into boundaries where trust and responsibility begin and end. After that, we'll explore the core characteristics that every cloud system shares. And then we will study delivery models, which are three main service types: infrastructure as a service, platform as a service, and software as a service. Finally, we'll finish with deployment models, the different ways the cloud can be hosted, like public, private, hybrid, and community clouds. These five areas give us the foundation to understand everything else about cloud computing. Understanding roles and boundaries. In cloud computing, two concepts matter above all: roles and boundaries. Roles define who is responsible for what, boundaries define what part you control and what part you have to trust someone else with. For example, the provider may be responsible for making sure that the servers are running, while consumers is responsible for configuring access controls. When these roles are clear, things run smoothly. When they aren't, there's confusion and potential problems. Boundaries make it clear where responsibility ends and where trust begins. Role of the cloud provider. A cloud provider is the organization that delivers IT resources as a service. They manage the infrastructure, which is the servers, networks, storage, and they ensure that these services meet certain promises, which are written in the service level agreements, which we discussed in the previous class, or in short, SLAs. Providers can be large players like Amazon Web Services, Azure by Microsoft, or Google Cloud. They can also be smaller companies that specialize in certain area, or even resellers who purchase services from a large provider and sell them on. The provider's job is to keep the systems running, secure, and available so consumers can use them. Role of cloud consumer. The cloud consumer is the one who uses these resources. This could be an individual using a Google Drive to store files, a startup running its app on AWS, or a company using Salesforce for customer management. Consumers don't manage the underlying hardware or data centers. They interact through dashboards, portals, or APIs. The key here is that the consumer contracts with the provider and uses the resources for their own needs without having to worry about maintaining the infrastructure. The diagram on the slide shows the cloud consumer connected to provider's resources. One side you see the consumer, which could be an individual, an organization, or even an application. And on the other side you see the provider's cloud services. Between them is an interface layer, usually shown as APIs, dashboards, or applications. The diagram makes the point that consumer doesn't touch the raw infrastructure. Instead, they interact with the provider service through interfaces that makes it easier to consume resources. This captures the key idea. The provider supplies the resources and the consumer contracts for and uses them without managing the hardware directly. Service consumers versus cloud consumers. There's an important distinction between a cloud consumer and a service consumer. A cloud consumer is a broader category. It can be people, organizations, or systems using cloud resources. A service consumer usually refers to a software application that directly calls a cloud service. For example, A weather app that makes a request to cloud based weather API is acting as a service consumer while the company is running the app and the people using it are the cloud consumers. This distinction helps us separate the technical use from the organizational use. Role of the cloud broker. A cloud broker is an intermediary between the provider and the consumer. Instead of the consumer dealing directly with multiple providers, a broker can simplify things. A broker may provide extra features, combine services from different providers, or help consumers find the best deal. There are three main types of brokerage: intermediation, which adds value to the service, aggregation, which bundles services from multiple providers, and arbitrage, which finds cost advantages. Brokers help organizations manage the complexity of using many cloud services. And as you can see from the diagram, it shows a broker sitting between the consumer and multiple providers. On one side, you see cloud consumers who need service, and on the other side, you see multiple providers offering different services. In the middle sits the broker, acting as a single point of contact. The arrows illustrate how broker simplifies the relationship. Instead of consumer juggling many separate provider connections, they just deal with the broker who aggregates them or intermediates those services. This makes the cloud ecosystem easier to manage. Role of the cloud service owner. The cloud service owner is the entity that legally owns a cloud service. This could be a provider if they created and delivered that service, but it could also be the consumer if the consumer developed their own service and hosts it on the cloud infrastructure. For example, Amazon owns and operates Amazon S3, but a company that builds its own applications and runs it on AWS is the owner of that application. Ownership determines who is ultimately responsible for the service itself, regardless of where it's hosted. Look at these two different diagrams. The diagram of the service owner here highlights the difference between the ownership and the hosting. It shows the cloud service which can legally belong to either the consumer or the provider. If the provider owns it, they control its delivery. If the consumer builds their own service, they still own it even though it might be hosted on provider's infrastructure, like here. The point of the diagram is to separate the concept of ownership from operation. You might own the service, but not the hardware it runs on. Role of the Cloud Resource Administrator. A Cloud Resource Administrator is responsible for managing cloud based IT resources on behalf of either the consumer or the provider. Administrators can belong to the consumer's organization, to the provider's staff, or even independent contractors. Their job includes setting up servers, configuring resources, applying security policies, and keeping everything running properly. In many organizations, administrators bridge the gap between provider resources and consumer needs, ensuring that services are used effectively and securely. This diagram shows that administrator managing resources on behalf of somebody else. You'll see the administrator position between the provider and the consumer needs. Arrow goes both ways because administrator can belong on either side. They might work for the provider managing their infrastructure, or they might work for the consumer configuring and maintaining the cloud resources they have rented. It shows that admin bridge the gap, making sure resources are properly managed regardless of which organization employs them. Moving on to additional roles in cloud environments, there are also supporting roles that make cloud ecosystems work. A cloud auditor is an independent evaluator who checks security, privacy, and compliance in the cloud system. They help in organizations confirm that provider is living up to their responsibilities. A cloud carrier is the network provider that delivers connectivity between the consumer and the provider. Without the carrier, the cloud services couldn't be accessed. These roles strengthen trust and ensure reliable communication between all of the parties involved. Concepts of organizational boundary. An organizational boundary defines the IT assets that are directly controlled by an organization. It doesn't always match the organization's full perimeter. For example, a university may control its on campus servers but not its outsourced student email system. Both providers and consumers maintain organizational boundaries to secure and manage their own resources. These boundaries make clear what belongs to the organization and what belongs to the external provider. The diagram below shows the idea of boundaries by shading the resources that belong to the organization. The organizational boundary surrounds the IT assets directly under the organization's control. Outside that shaded region are the resources owned by the provider. It makes the point that boundaries aren't about the whole company, they're about specific IT resources that one organization governs. Concept of trust boundary. A trust boundary defines how far an organization must extend its trust when using a cloud service. When a company uses cloud infrastructure, it has to trust the provider's system and infrastructure to handle its data and applications. This trust boundary goes beyond the organization's own assets and into the provider's environment. Understanding trust and boundaries is critical for managing security since it shows exactly where the organization must rely on an external party. The diagram for trust boundaries extend beyond the organizational boundary. It shows how the consumer must place trust in the provider's system when using a cloud service. The trust boundary is drawn wider than the organizational boundary, covering parts of the provider's environment. This visually communicates that cloud computing always requires extending trust beyond your own infrastructure. Defining cloud characteristics. Cloud environments all share a set of defining characteristics. These traits are what make cloud computing distinct from traditional IT setups. They include on demand usage, ubiquitous access, multi tenancy, resource pooling, elasticity, and many more, and also resiliency, which is very important. Together, these characteristics form a core value proposition for the cloud: scalable, flexible, and efficient, that can be delivered as a service. Characteristics on demand usage. One of the most important feature of cloud computing is on demand usage. This means consumers can provision IT resources whenever they need them without needing to contact the provider directly. This process can be automated and services are usually available immediately. This flexibility allows organizations to move quickly, experiment with new ideas, and scale up or down as required. So, another core trait is ubiquitous access. Cloud services are designed to be reachable from different types of devices and platforms. Whether you're on a laptop, tablet, or a smartphone, you can connect to cloud services. Providers use multiple protocols, interfaces, and security methods to make this possible. Ubiquitous access ensures that users can work from anywhere at any time on nearly any device. The next part of this chapter would be continued on Wednesday. Thank you.